Hare Krishna. Hope you are doing well. Let's get started with this question, which is about characteristic roots, and eventually we will see it's going to be about quadratic discriminant as well. The question is simple. You are given this general form of a matrix, and you are asked how many characteristic roots are real. Okay, let's get started. Okay, starting with theory, characteristic roots of a matrix are its eigenvalues, and the way to find eigenvalues is this route where you take the matrix minus lambda, which is scalar, variable but scalar, multiplied by the identity matrix, and the determinant of that for which values of lambda is it going to 0. So this becomes, okay, this is the M matrix minus lambda times identity matrix, the determinant of that, which goes to this. Now we can simplify this by summing up all the rows, so that on top in each cell of the row we'll have a plus b plus c minus lambda, which we can take common in the determinant. Then for the remaining structure, we can subtract the first row from the second row and the third row, so that we get this, which now becomes just a simple 2 cross 2 style, this thing. So we already have factored out one real value of lambda, which lambda can take, and a plus b plus c. Now this part gives this quadratic expression. But the thing is, and this is where it can cost you time, you are not told to find the roots exactly. You are just told tell whether the roots are real or not. And in order to judge that, to assess that, we get something known as the discriminant of the quadratic equation. So essentially, if the equation is like lambda square plus lambda plus c, where these are the coefficients, then the discriminant is b square minus 4ac. And if this thing is negative, then the roots would be imaginary for any general quadratic expression equation. So this thing is simple to find, like this thing becomes the square over here minus 4 times this and this, which simplifies to this, which is less than 0, because they gave you this thing, right? So the remaining two roots coming from this portion are complex. But the thing is, there could have been another way to go about this. Remember, it's a general question with a specific answer. Now, if you don't understand what I mean by that, you should watch the introduction video of these series of questions for IIT Jam 2025. You'll understand. If we think about it, if we are able to think about it during the moment of exam, what could be one convenient matrix structure that gives us the answer very quickly? The direction, if the dots are connected, is the skew symmetric matrix, because we can take a as 0 in the diagonal position, b we can take as minus c, so that we have m transpose equals to minus m. And if we happen to remember in the exams that skew symmetric matrices only have 0 as eigenvalue, or complex eigenvalues with the imaginary part, we could understand that this thing over here has just one real eigenvalue 0 and others are complex. So because for this specific setup there is just one real value, and there has to be just one answer to this general question, this answer will be the correct answer. So honestly, in the exam I would have done something like this, tried to do something like this. All of this theory is just something good to have if you remember it. Take care. Hare Krishna.